Pleasure to be here. Firstly, just to let everybody know, I'm actually tethering because I've lost the internet. So I'm going to go off camera. I'm going to spend the next kind of 35 minutes talking about implementing reliability for a post-pandemic future. So we're going to talk about, what is reliability and why, and who needs to care about it. We're going to talk about what I deem personally as the pillars of reliability. That's a very much biased view that I have, and hopefully that will aid some debate. And then finally, in this new world that we're kind of, this new era that we're moving into, what are the kind of things that will enable us to bring success? So my name's Steve Wade. I'm an independent consultant and trainer. You can find me at the links that are listed there. Feel free to reach out post talk if you want to continue the conversation. I just want to stop and pause for a second and say, with the pandemic that we've had, we're trending towards the end of this, hopefully, and we've all with the strength and resilience of all of us, we're finally seeing the light at the end of the tunnel. So what are we going to talk about? Again, we're going to talk about who should care about reliability, the pillars, and some requirements for post-pandemic success. And then, as Adele said just a minute ago, I'll open it up for a Q&A. So we talk about reliability a lot from the context of software engineering. We ask questions about service availability or how important it is for specific users. But when organizations face outages, it becomes immediately obvious that the reliability of an online service or an application is something that impacts the entire business with significant costs. So let's compare two different incidents. So one causes lag briefly for a service that everyone, including your most valuable customer base, uses. The other causes a total outage for an hour, but just for a service with a very small percentage of users who are generally on a low tier subscription and very rarely access this piece of software. Which one causes more damage to a user's perception of reliability? And I think being able to answer this question is key to having, and thinking about reliability and having a framework to answer and ask those important questions. So since it's fundamental to the entire business, engineers alone shouldn't be the ones thinking and planning about reliability. Having reliability inform the decisions that every team cultivates is on the Google reliability spectrum. It sits you in the strategic and visionary phases of what they call the reliability spectrum. And I've left the link down there if you want to go and have a further read. It isn't about checking off certain milestones, but it's more about, working as a team and looking at the benefits as a whole of reliability and how you can implement them across your whole entire organization, not just your code base. So different teams within an organization can have very different perspectives and priorities. So if we think about a product team hoping to release an important new feature as soon as possible, or an operations team looking to reconfigure the CI/CD process, or even further than that, a customer success team trying to drive a development roadmap in response to some customer feedback that they've had. These goals all conflict each other, and each team's perspective and desire to complete their project wanting it to take priority is completely valid. So how do you as an organization come up with the answer to which one comes first? All three teams have valid claims that their priority is is essential to user happiness, but these users are different, right? So one is focused on the current customer base, one is focused on developer teams, and then the other one is focused on prospective customers. So we can't simply compare the number of users affected to, how important or how reliable this new feature is going to be. So we need a common way of making decisions. right? And we need to ask this, a set of questions. So what are the types of users, that are likely to be affected? What are the frequency of the affected user experience? What's the importance of the aspect of the user feature? Like, how important is it to the user? And then what is the business importance of making sure that the affected user is constantly satisfied, right? Our ultimate goal is to have some kind of metric that encompasses how much user satisfaction could change based on a decision that we are about to make. And this metric would apply not just only to code changes, but decisions by any team at any level of the organization. And by having a way of being able to make decisions, we create a kind of universal and well understood language, which we can use to discuss user satisfaction levels and therefore business impacts. If we've established this kind of, this definition of reliability that everybody in the organization understands, we'll have a much better position to prioritize each project or each team's desires based on the impact and overarching goals. However, this might not be just as simple as seeing which ones make the biggest positive impact or the ones that have the potential, lowest negative impact. We need to have a way of baselining these. So improving the reliability of a service that users are happy with may not be appreciated or even noticed by the majority of your user base. So trying to indefinitely improve reliability has, rapidly mounting costs and potentially diminishing returns. So what's important is the ability to be able to maintain reliability at a level that doesn't cause user pain or friction. If we are causing user pain or user friction, we are making the product be deemed less reliable, and therefore we're giving the customer or the user a worse customer experience. And we need some way to be able to, obtain information about the changes that we are making and what impact they have on our customers. And it's important not just to agree on what reliability looks like from different user experiences, but also to determine the point at which each user experience becomes too unreliable. Like, this is what we're going to get onto when we talk about service level objectives. So how each user experience is being compared to that agreed upon objective determines how we prioritize changes across the business or across your teams. So having this kind of framework and this language that we can talk about throughout the organization that provides us with a view of what reliability means for your customers is going to be critical to quantifying and weighing up decisions at all the different levels of your organization. And it also gives us the ability to plan investment payback. So what do I mean by that? Anything that we do at an organization has some kind of investment behind it. Think new hires, think implementing a new tool, think implementing new policies and procedures, right? They all have, they all take investment. And each one of them has initial costs, but with the experience, will the experience ultimately create value that is more value to the user than the cost that it takes to implement it? We can't think about changes just in a narrow financial focus, because it's hard to put a pound or dollar value on many of the returns that you'll get from implementing reliability. Potential challenges caused by this kind of investment could include issues caused by teams getting up to speed with a new policy, reprioritizing other projects to implement a new tool, or the loss of resources that could have spent working on user experience. And I think when we talk about an investment can look like it's going to have a big payoff, but for a very small cost. But if that small cost pushes the user experience over the edge and causes user pain, then is it really worth implementing a tool? So different business functions think about reliability differently, and how it impacts user satisfaction. So if we think about revenue teams or marketing and sales, their decisions don't directly impact user experience for the product. However, what they do is they impact the user's perception on how good the product is, right? And exceptions can change where the satisfactory point is for a user. So on the other hand, lowering expectations will also lower interest in your product. So like any other team, even revenue teams have to achieve or align their goals with making sure that we don't sacrifice reliability or a customer's perception of reliability. And I think finding the connection points through reliability and user satisfaction across all of the functions of your business is critical to driving decisions, right? Whether those decisions are bottom up or whether those decisions are top down. It allows you to understand the impact on what the decision is and the goals that it's going to have, again, with every team. So I'm going to start throwing out some acronyms here. So SLO, SLA, and SLI. So the goal of an engineering team is always to ensure availability, performance, and the ability to be able to monitor their services. And this gets broken down even further into effectively writing policies or procedures to ensure these goals are being met, even during emergencies or incidents or outages. So if we start with a service level objective or an SLO, they are internal goals for your service level indicators, which we'll come on to in a second. They aren't shared with external stakeholders and they have no legal bindings or consequences against them. But what they can do is they can help ensure that our SLAs or our service level agreements aren't breached. And they kind of allow us to keep in this, this safe space away from any legal trouble. So because of this, SLOs should always be made stricter than the corresponding SLAs, and that gives us that buffer room. And the service level objective, or SLA, is a legally binding agreement now between an organization and their customers or end users. And it guarantees that their service will meet certain agreed upon reliability standards. So these are usually built on simple, objective, and strictly defined metrics. So for example, we could have an SLA that says our service will be online 99.99% of the time. There's no nuance or debate to that metric, right? The service is either online or it's offline. And generally, SLAs are a type of key performance metric that can be monitored by outside observers without having to have internal monitoring data. So this allows stakeholders to verify for themselves that the SLA is being met. And a good SLA will be ambiguous, as it needs to be legally binding while still considering all stakeholders' needs and factors. And also, because it's legally binding, there's this legal strictness to it, whereby it's unlikely to change a lot because it's going to take a lot of time to change and also a lot of effort. An SLI, or a service level indicator, is a metric that defines the health of a service over time and is used to determine whether the service level objectives are being met. So setting the right SLI is about understanding what the user expects from a service, right? You've got to get inside the user's head. You've got to think, what kind of uptime, what kind of service do they want, or experience do they want from this product? And then how can we track where that starts to dip or that starts to go down, and subsequently when can we start to see it rise and them having a positive experience? And you don't want to use every metric that you have available to you. in a monitoring system to work out what your SLI is. In fact, from previous experience, choosing too many SLIs can make it difficult to pay attention to the right metric. You're going to get burdened with a load of noise, and you're not going to know which one you should be listening to, which one actually is, the key user experience that's actually being degraded. And if the service level objective drops below a certain point, the service provider or the team that's responsible for that service needs to take the appropriate action in order to increase availability. So really, the SLI is worked out by the total number of good events divided by the total number of events wholesale times 100, and that gives you a percentage. So an example of an SLI may be the number of successful HTTP requests divided by the total number of HTTP requests that your service has inbound, or the number of HTTP requests that have completed successfully in sub 100 milliseconds against all of the total inbound requests. Right, and there's many different variations to this, but a way of being able to diagnose or indicate whether your service is healthy and providing good customer satisfaction and customer needs, and when it's not, is going to be critical for you to get ahead of your user. What we don't want to happen is the user tells us that the service is being degraded. We need to know that the service is being degraded and act on it. Right? And if we remember back to that bell curve, it's the reactive and proactive. We want to shift ourselves to getting into the proactive category. If we're in the reactive category, the customer is 9 times out of 10 going to have a bad user experience. So that kind of sets the scene a little bit for some of the terminology that we're going to be talking about, and also the fact that reliability is important to everybody in the business. There's a common misconception that it's just important to engineers. So what are my pillars of reliability from my perspective? So I come from an engineering background, so this is kind of going to be slightly biased towards engineering teams. But the goal of any engineering team is to ensure, availability, performance, and the ability to be able to break down and monitor our services. So the first pillar for me is all about the SLO. So because availability and performance are crucial aspects to monitor, right? But how do your users view them, right? And what matters most to those users? And SLIs and service level objectives, or SLOs, they play a significant role here because they encourage teams to think like users, right? Once developers and engineers start to think like users, they start to ask different types of questions. And SLOs accomplish this because they provide a tool for measuring and validating service health. So SLOs are designed based on a user's point of view and the factors that matter most to them alongside the business requirements. So the service that you're writing or the products that you are writing may have, hundreds or tens or hundreds of features, but what are the core features that the users are using day in, day out that are the most important features for your product to be successful and for you to provide a positive user experience? So I consider SLOs a pillar because they reflect a user journey and make customer happiness a metric, right? And therefore, that's a priority. If the customers are unhappy, they're not going to come back and use the product. So crafting and creating SLOs that reflect what users want gives development teams a roadmap to follow. Once we get in the mind of a user, we start to think about, how useful is this feature to the user? Have I implemented this in the most simplistic fashion? And we'll come on to simplicity shortly. And it shows a better understanding of when to increase development velocity and when to focus on improvements, right? Product managers, they always want the latest feature, and it's very difficult sometimes for engineers to get improvements bumped up the priority list. But if you can show with data that your SLO is decreasing and you need to work on stability and and focus on improvements, that conversation becomes much easier. Just you stating it in a sprint planning or on a one-off meeting with no data makes it very difficult for them to necessarily consider the fact that you want to work on improvements. Building SLIs, we need to look at how our customers are using our services. And that comes back to understanding user journeys and considering what are the most important and essential flows through our system. And we need to set our SLOs at the customer's pain point, right? What can cause the customer the most pain whilst using the product or this specific feature of that product? And we need to ensure that SLOs are monitorable. If we can't monitor them, then we have no way of knowing whether we are succeeding or failing at that service level objective. We need a way to get at the data that we need to make sure that we can keep the SLOs up to date. And we need to make sure that anything that could affect the SLI is being represented, right? We need to set policies, error budgets, which I'm going to come on to in a second, and one of the things that I would always recommend doing is review and revise these SLOs over time, right? As your services change and grow and you implement new features and, what becomes important to customers changes too, you need to set a schedule to review the SLOs that you previously had and make sure they still reflect customers' happiness. Because if they don't, you have SLOs against things that may not be important anymore. So error budgets, another pillar that I think is very important because they can be set between teams and refer to the number of errors that can accumulate within a service or product before customers get upset. So now we're in the internals of a service. A product team is talking about, what do we deem as acceptable, and what's our upper and lower bounds. And errors can be caused by various issues within the product, availability, performance, downtime, scalability issues. There's in this kind of microservice architecture that everyone is leaning towards, and containers and cloud-based offerings. There are a number of factors that can cause errors to happen. It's not just the application itself. It's up to the team to first identify what they're trying to measure for. So the error budget itself will vary depending on teams, but it's calculated using the SLI or the service level indicator equation. And the percentage that comes from this equation is referred to as the SLI, and each one is assigned an objective. And the remainder of what's left is deemed your error budget. So error budgets serve many vital purposes, right? On the surface, they're essentially metrics to understand how products or services are running. But when you look deeper, it's actually more than that. For example, if the budget is close to being exhausted, you may trigger policies to prevent it from running out. This could include things like code freezes, where no new updates are allowed to be implemented, only improvements. Or you may even roll the version back. You may go back a version because the previous version was more stable than the one that you've just rolled out. It also provides you and gives you this understanding of some breathing room, as you're able to tell when an incident won't jeopardize the error budget and you don't panic as much. So if error budgets aren't spent, it gives development teams leeway to innovate and take more risks to launch new features and improvements to customers. If it's trending towards being breached, then developers and engineers need to be focused on reliability and improving the performance of that single microservice or maybe a set of microservices that provide a feature. And really, when you think about an error budget is the amount of acceptable unreliability a service can have before the customer's happiness is impacted. So if a service is well within their budget, then the developers can take risks. And if they're trending towards their budget, then they can take less risks. And error budgets normalize failure as a part of the development process, right? It allows us to make mistakes without getting caught by our customers. We're never going to be able to implement everything perfectly 100% of the time. But what this enables us to be able to do is be able to determine when we have implemented a problem and be able to, take time out of the normal development cycle to implement improvements and to make that product or that service more reliable. As well as that, the error budget provides solid data to development teams on how to set release velocity, right? So a very common misconception is that error budgets are consumed in one continuous chunk, right, with a single incident. But that's not always the case, right? There's many scenarios that can happen, or many incidents that can happen, where the error budget is actually consumed in small portions throughout maybe a week, a month, or a year, and that's perfectly acceptable. So suppose we have a payment service. I come from a financial services background, so I'm going to talk about payments. We have a payment service that has a service level agreement of 98%. So we know that a service level objective needs to be higher than a service level agreement. So we're going to set the service level objective to 99% availability. So our error budget in this context is 1%. That's the difference between the SLO and the SLA. So then let's say that 1% is in a 28-day window, right? That's a normal month. That gives us about 3.5 days of downtime. Now let's assume that after 15 days, the SLI is 99.5. So we're meeting our SLO and we're within our error budget. However, if the service level indicator drops below 99%, then we've used up our error budget and we're no longer meeting our SLO. And if that happens, then we need to take some corrective action. This is a table that I use quite regularly when I'm talking about, SLOs, and the common conception that everyone says, I want 5 nines of availability. So 5 nines being the second from bottom. So that gives you an error budget per year of 5 minutes and an error budget per month of, just under 6 seconds. You have to question whether that is possible in the services and applications and products that you're providing. And also another misconception is, setting the SLO to be more strict than the underlying infrastructure that your application runs on. You can't get any more reliable than the infrastructure that you're currently running on, because that's the lowest common denominator. So if the infrastructure that you're running on only provides you with 4 nines of uptime or availability, then you can't possibly have an SLO for your application of 5 nines. It's just not going to be possible, because the infrastructure is obviously going to win out at that point. And an error budget is really reliability versus pace of innovation. That's the kind of that's the question that we're asking ourselves. Which one of these can we push more? Innovation means change, and the main reason behind instability is change, right? And the development toil for new features is always competing with the developer toil required for sustainability or stability, sorry. Change is inevitable, right? And therefore the error budget works as a control mechanism to provide us and make sure that we set attention when stability is being degraded. So how can developers spend their error budget? So an error budget to me is kind of like, a budget or having a budget that you've been given by your parents. They've given you £100, you can go and spend it on whatever you want. And it's the allowed expense. And by allowed expense, I mean unreliability. You're allowed to spend your error budget within a given period, as long as you don't overspend it, right? So you can't go over your limit. And developers can spend the error budget any way they see fit. They can spend it doing providing new features, working on new functionality. But as the team advances in the maturity and gains better control over how to spend their error budget, they begin to strategically spend their budget by taking more calculated risks, right, and shipping experimental features. What do you do when you're close to or you're going to spend your error budget? Well, firstly, you need some way of being able to alert on this. So I normally go with the 50, 75, 90, and 100% as an example. And, if we're trending towards those top level percentages, then we need to make a decision. And like I said before, that could be rolling back to the previous version that was more stable, or that could be stopping shipping new features and working on making the current version of the product more stable. The next one is eliminating toil. So toil is the amount, reducing the amount of repetitive tasks that a team has to do. By eliminating toil, we're going to free up energy and time to perform other tasks. This also increases morale and allows the team to focus on what they would deem to be more interesting work. And you can eliminate toil in many different ways. That could be writing guides or processes for tasks, or that could be by documenting specific flows through the system so that new joiners can read documentation to get up to speed and start adding value to your product team. And I think the real way that you start to implement this principle is creating standards and templates, right? Make guidelines, invest in tools that you need to automate some of these manual tasks. And look for areas of high toil, like things that are common and time-consuming tasks. And prioritize improvements, like include toil elimination in sprints, plan time for regular improvements, right? Improving things makes everybody's life better in the future. Moving on to monitoring. So monitoring is a key pillar in reliability, but the key thing here is what is necessary. We don't need to monitor absolutely everything. We need to monitor stuff or metrics that we can act on and we can make changes based off of. So we need to have actionable data, right? That we can make changes from. And it's very tempting to log every single line or every bit of information that you can get out of your service, right? But what ends up happening is too much data can be overwhelming, right? And additionally, like too many metrics can become misleading, false positives. Which one of these 10 metrics that my service is emitting is actually the most important one? But there's tools out there nowadays that allow you to collate metrics and monitor your services. Tools such as Prometheus and Grafana and the Alert Manager, tools like that are open source and available to you to provide and facilitate monitoring at your application level, but also at your platform level as well. And there's a lot of custom and out-of-the-box dashboards that mean that we don't have to keep reinventing the wheel and everyone build the same set of alerts and dashboards. And I think the most common metrics that I would focus on from a reliability perspective are the 4 golden signals. So latency, the time it takes for a service to respond to a given request; traffic, the amount of load a service is currently experiencing; the error rate, which is how often do requests to the service fail, think error budgets; and then saturation, how much longer the service resource will last, or how saturated the service is. Do I need to scale out, as an example? And these are often the metrics that you'll use to measure components of your service level indicators. So keeping an eye on these metrics can allow us to understand our customers' happiness. Release engineering is another pillar, which means building and deploying software in a consistent, stable, and repeatable way. And from the kind of there's many principles around releasing software and how we can release and have a good release engineering strategy. So things such as configuration management, creating a singular agreed upon standard for how releases can be configured across the organization, or maybe just in your product team. Some releases may need some changes, some releases may not need any changes. Maybe you're just bumping up the version of a container or a binary. Process documentation. So investing, creating guides for different types of releases, right? Anything that we can do to make the release or a release easier or smoother is going to provide much more benefit and make the whole release process much more reliable. When we change something or we release something, we may or may not make it more or less reliable than it was previously. So having automation and testing around our release process, having this mantra of continuous testing, or of a process of catching errors as soon as possible. So running automated tests, not just in your downstream environments, but also in production if you can. So pretending to be the customer so that we can understand and figure out, what impact our change is having on our customer base before the customer actually sees it. Simplicity. So simplicity is around, trying not to develop the most complex system that still performs as it's intended, right? And I think with this concept of microservices, you can get into this Hiroshima bomb, where hundreds and hundreds of very small microservices come up, get created that do one thing and do one thing very well. But the overall architecture now becomes ridiculously complicated because one service could be talking to 5 others. And how do you manage all the relationships between them? And how do you make sure there's no breaking changes? And systems trend towards complexity as new features are introduced. So we need to consider the cost of additional complexity when proposing new features. And we can use user satisfaction as our kind of standard. Will these features contribute enough business value to offset the level of complexity? I think, how do we implement that? Well, we need to have metrics that evaluate the complexity of a system, and being able to evaluate the development with simplicity in mind. So when designing new features, having that business value to complexity trade-off and setting standards in a way of being able to obtain whether something is overly complex. So what are the requirements now for post-pandemic success? So things have changed in the last couple of years, that we're not all in the same office, as a prime example. We're all working remotely. Some people are in the office and some people aren't in the office. But I think there's some requirements that we need to all get on board with that will make the post-pandemic future much more of a success for everybody. And I think the first one kind of comes to reworking the term technical debt. So when I go into companies as a consultant and I say the word technical debt, it just brings fear to everybody, right? They often view tackling technical debt as some kind of major project that will impede all other features that are being developed. But in a healthy system, technical debt management is, it should be a routine cleanse. We should be sweeping up the technical debt behind us. We shouldn't leave a mountain of technical debt that will never get dealt with. And the concept of debt is a total misdemeanor. If you think of it as debt, you'll think of it as the enemy of velocity or the enemy of innovation. But in reality, it brings stability, which will therefore be able to support innovation and velocity. And by taking the fear out of technical debt, companies can use it as an opportunity to support innovation while still optimizing, and guaranteeing a reliable foundation. It's important to make sure that now that all of our teams are safe psychologically and able to learn from their mistakes. The next outage or major incident is going to happen. It's right around the corner, and that's okay. And that's the mindset that we've got to be in. Failure is going to happen. We just need to be able to deal with it. And COVID-19 has accelerated the urgency for digitalization. And this creates a tremendous amount of pressure and stress on the people and teams who support digital services. And this stress can lead to the blame game, right? However, blame should not be directed at the person. It should be directed at the system. So why couldn't I access the data? Why was there no metric? Why was there no alert? Why was there no runbook? Not, how did you not realize that you shipped this feature that caused this problem? And this concept of visibility will, empower our safety. Like with observability, teams are able to gain deep insight into these distributed systems, better understand gaps in tools and processes, and move away from the blame game. Based on the previous slide, bringing observability to the forefront now allows us to see into issues and learn from them in depth, right? Without an observability strategy, like every team is just in the dark. They have no idea what's going on, when it's going on, or what's causing the problem. So to prevent this, I would encourage you to encourage your organizations to focus on observability early and revise it often. Right? And there's many tools and vendors that provide you with the ability for you to be able to bring observability to the forefront. But we need to allow engineers and the ability to be able to see the data, whether that be metrics, logs, traces, and be able to get to the root cause of the issue. And to begin with implementing observability, I would encourage your teams to identify critical user journeys through the system and break them down and prioritize them into the top 3 categories of user flows. And teams must recognize the most crucial flows and implement observability based on them. The more insight we have into those critical flows, the more we can understand how the user is using the system. And for teams looking for a place to start, I'd recommend going and talking to the testing team, because the testing team has probably got a set of user flows that they've already got documented. Continuous documentation and communication, right? As recent events have forced us into remote working, we need to support seamless collaboration through processes and also through tooling. We need to communicate, interact, document, and make information available to us. That is even more important than it was 2 or 3 years ago. And this concept of asynchronous communication, so there's people working and spanning different time zones, and documentation serves as a much needed way of being able to gain understanding without having to have a video conference call. And it's more than ever essential to start writing things down, right? And making sure that the team's on the same page. We can't have that person, like that you'd call into an incident huddle because they know the most about this. That person may not be available at the time that incident happens. They may be out for a walk. They may be taking some time away from the computer. Not everyone is having, the same standard lunch break. People are switching, the time that they take off away from the computer. We can't rely on the human being there anymore. And us learning to thrive in this post-pandemic world is going to be an act of resilience on all of us, right? And we can learn how to make our systems and people more capable with understanding all of the bumps along the way. And by adopting observability early and revising it, by focusing on documentation, communication, and I think most importantly, focusing on the people, we can enter into this new era stronger than we've ever been before. And I want to leave you with a closing remark that reliability is a team sport. It's so fundamental to business success that it can't just be the focus and reliability of, and responsibility of engineers. Instead, every team needs to align on what reliability means and how they can prioritize work and features based on it. Thank you very much. So I'll start with the question in the chat first, and then feel free to jump in and type in the chat box or just come off mute like Adele's saying and ask the question. So Charlie, you said, how would you say the importance of reliability differs between product teams with different size user bases? Is reliability more important for a product with 10,000 users than a product with only 100 users? So I don't think, from my perspective, the number of customers doesn't necessarily matter. It's about the experience that those customers have, right? And every customer is important as the next customer, but some customers may be paying for, you know, a higher standard, or think about the licensing model. They may be paying a higher license fee, so they would expect a different or a higher level of reliability. But what I like to talk about with customers that I go into is having a baseline of reliability across the product. So whether you have a product that has 10 customers, 100 customers, 1,000 customers, your baseline doesn't move, right? It's still there no matter what the customer base or what the customer number is. But how many flows through the system will you allow to fail over a period of time? And to me, the number of customers doesn't matter. It's just a simple numbers game. So obviously, as the number of customers increases, the number of requests or the number of flows through the system may or may not increase. But it depends upon the user flows through the system. Like I was talking about before, not every flow through the system is a commonly used flow. And if we think about like banking systems, for example, or like financial services where I come from, checking your balance is a critical flow that every single customer is going to use. But creating an invoice is not a critical thing that everybody's going to use all the time. So the error budget or the service level objective for the looking at your balance is much more stringent compared to the ability to be able to create an invoice. I'm not too bothered if at some point in time the ability to be able to create an invoice is not possible, right, for a period of time. If at all no one can view their balance ever, we have a major problem, because a bank is all about the ability to be able to see your balance and know your ingoing and outgoing cash flow. And if they can't do that, that is the top level, most critical user flow through the system. So when I was at a business digital bank before, we started with a very low customer base, but I left with a very high customer base. But the error budget was always the same. We would allow the most minuscule amount of issues when people were viewing their budget, because that was such a critical flow through the system. So to kind of answer your question, for me, the number of users doesn't matter. It's the customer experience that really matters, and how much of the customer experience you're willing to affect over a period of time. And that's a sliding window. And it's up to you as an organization to put it in a specific time frame. So I always used to talk about a week, 2 weeks, and a month, and what were our budgets around those windows. Anything further out than that is difficult, because you don't know, to your point about users, you don't know how your user base is going to grow necessarily over the next 3 months. But what we do know is we know how critical our flows through the system are going to be over the next 3 months, because some of them are such core flows that they're not going to change. New flows through the system is a bit of a guessing game. You're never going to get it right first time, right? It's something that you're going to have to iterate on whilst that feature is being used by customers. And then once that feature kind of goes into being GA or generally available, that's when you kind of set your line in the sand. Charlie, I hope that answered your question.
Hello, Steve. I've got a quick one, if I can.
Sure, no problem.
How do you find from teams you've seen, if you met, how reliability is perceived? Is that felt like a problem, I mean, that someone else has to deal with, like the ops or something like that, or is it like the hot potato that everyone like bounces around, or have you felt that people are more and more at least aware there is a question here?
I think that in a lot of experiences that I've had before, it's that hot potato, right? It's not my problem. It's not my problem. Oh, it doesn't affect my microservice, so therefore it doesn't have anything to do with me. But I always go into companies and I say, like, I always use this mantra of the whole engineering team succeeds or fails together as a unit, right? It's an engine that works together, and there's many component and constituent parts to that. No, not just because the reliability of your service is like really, really high and you don't have any error budgets and you never break your SLI, and another one does. How can you share ways of working to make sure that you try and get to the same standard, right? And I think before, in companies where I join early, it's always the blame game. It's everyone else's problem. It's the platform engineering's problem because the platform fell over. But when everyone starts to think about the product as a whole and, succeeding and failing together, everybody starts to come together. And it's the responsibility of the whole engineering team, not just the product team that's working on that feature. And it's a people problem, right? The technology, I always say it, the technology is the easiest part. It's the people problem. It's the people that make the problems difficult. And I think that once you get everybody on the same page, it's very difficult, by the way, but once you get everybody on the same page, you make having conversations about reliability a lot easier. So one of the things that I did in the past is I implemented the concept of SLOs, SLIs, error budgets into the core flow through the banking system. And what is the core flow through the banking system? It is the ability to be able to see your transactions input, inbound and outbound all the time, no matter what. And how did we go about implementing that? We screwed it up the first 3 times. I'm going to be completely blunt and honest with you, but we learned a hell of a lot of lessons. Then what I did is I used them as ambassadors, right? And I used them as a way of being able to market this as a way of working. And they went out and dissipated this information and this usefulness of thinking about reliability to other product teams. They had less outages and less incidents than all of the other product teams. They were the ones that were getting paid to be on call and basically never being woken up. And all of these other product teams were. And then once they started to go out and have conversations and tell people why they were never being called out and how they'd implemented all these things, the switch just flipped. Everyone wants free money, right? If you can be on call and never get called out, that's the holy grail. And being able to put things and practices into place and having people that are your voice without you as the person, or the consultant that came in and started it is gold dust, right? They're doing the marketing for you. And they have the data and the ability to be able to prove it. So I think for me, it's start with one team and get them to market this for themselves and tell other product teams why it's so useful. And then, it's just a domino or snowball effect at that point.
Makes sense. Thank you very much, Steve.
No problem.
Okay, so I think, we've got one more question.
Charlie said, how often would you say an organization needs to review its SLAs and SLOs? What sorts of situations and conditions might affect the length of time between reviews and different services? So I think that it's important to, no matter what, regularly review every quarter as an organization. So no matter what happens, when incidents of certain levels or certain categories happen, the need to review becomes more urgent, right? If you get a really critical incident and you're offline and you blow everybody's error budget out because you've had to take the service offline for, say, 3 hours, 5 hours, half a day, whatever it is, then as an engineering group or as a company, you need to come and review those SLAs and SLOs because something has just blown them out of the water completely. So I think it's very difficult to give you an exact answer. I would say every 3 months at a minimum, and more regularly if an incident happens that blows out multiple error budgets from a single incident. Once it crosses and spans different features or different flows through the system from a specific type of incident, then questions need to start to be answered. But you've got the data that proves that, right? And what's happening at the moment and maybe happening in your organization and other people's organizations is you just don't have the data to be able to answer the question. And once you start to have these indicators and these error budgets, you can start to prove that incident that happened last week sent our error budget, right the way down, and now we can't innovate. We have to work on reliability, even though it wasn't directly correlated to the service that you were working on. I hope that answers your question.